An important application that we are going to have to do a lot in this class is motion in a ramp. So let's just look at that. So motion in a ramp, we have something like this. We have a ramp or some inclined road or something, and then there is an object moving in there. And so we would like to study the motion of that object. And so we can draw a free body diagram. So imagine that there's gravity pulling this thing here. So you know this guy is going to move in this direction. So the free body, the motion diagram shows the vectors here. These green vectors are the velocity vectors, and the acceleration is a constant vector. So what we would like to know is what is the component of the acceleration vector in an x direction if we use this tilted coordinate system, right? So we have this tilted coordinate system, and we would like to know the component of the acceleration. Remember, the acceleration of the object is gravity, right? Gravity, and then gravity would have two components, one in the horizontal direction and one in the vertical direction, and we are interested in this one. What is the value of this one given this angle here, theta? So and we can decompose the vector, so find the components. So this is your vector, which is basically g, right? And then it has two components, ax and ay. And you can see from trigonometry that ax, well, this goes with the sine of this angle, right? This is your triangle here. So ax is equal to a sine of theta, or g sine of theta. So that's all there is to this motion in on a ramp. So let's apply that to a simple problem here. So what is the maximum possible speed for a skier? Right, so then the skiers are going to start from rest in this place in the past ski area in Oregon, and then they accelerate downward on a stretch of the mountain with a reasonable constant slope. So they aim for the highest possible speed at the end of this run. During this acceleration phase, the skier traveled 360 meters while dropping a vertical distance of 170 meters. What is the fastest speed that a skier could achieve? So let's look at a picture. This is very important here. So we have a picture. So it says they traveled 360 meters, right? So this distance from here to here is 360 meters. And this drop here, from here to here, that is 170 meters. Okay? So what do we know? We know the initial position, we know the initial velocity, and we know the final velocity. We want to find the final, we know the final position, and we want to find the final velocity. So this is a one-dimensional motion like the ones we studied over the last 3 weeks. So to find the final velocity, we need to do final velocity is equal to initial velocity plus acceleration times delta t. We could do that, but that's not going to help because we don't know the time. So we can use the other equation, which is final velocity squared is equal to initial velocity squared plus 2 times acceleration times delta x. And now that helps because we know delta x, this is 360 meters. We know the acceleration, right? The acceleration is going to be given by the acceleration in x, which is a sine theta, which is equal to g sine theta. And we know this guy, which is 0, right? Because we start from rest. So let's put some math here. So the first thing we need to do is find this angle theta. So remember, sine of theta is equal to opposite divided by this length here. So this would be what, 170, which is this one here, divided by this one here, which is 360. So that is the sine. So 170 divided by 360, that gives me the sine of theta. and that gave me an angle of 28 degrees. So now I need to find the acceleration in x, which is g sine theta from our previous slide. It's 9.8 meters per second squared times the sine of 28 degrees, which is 170 divided by 360, and so that would give me 4.6 meters per second squared. So that's the acceleration in x. So now I applied the previous formula. Velocity final squared is equal to initial squared plus 2 times the acceleration in x times delta x. And so the initial velocity is 0. So the final velocity is the square root of 2a times delta x. That's 360 meters. This is 4.6, and I get that that's 58 meters per second. So that is the possible maximum speed. However, this is only true if there was no friction of air resistance. In real life, the skier is going to have some air drag and some friction from the skis, and that's going to decrease the speed. So this would be the final speed in ideal conditions. So final speed of 58 meters per second gives you 130 meters per hour. So, but it's going to be less than that because of friction and air resistance.